Well, here's my good old Icom 746 Pro. It's my ham radio. Old trusty radio finally gave up the smoke. We're going to figure out what happened. So, about a month ago, I went to just turn on the radio for some leisurely evening chats, and thing caught on fire. What can I say? The thing literally flamed up in the back, right where the power supply plugs in. His power supply here, right in the back. This plug, wham! There it is. This plug plugs in back here, and that thing just lit up. And so today we're going to open this thing up, see what caught on fire, see if we can figure out why, see if we can fix it, and get this thing back on the air. Fingers crossed. Alright, so here's the power plug right here, and I was expecting to see something obviously burnt right in this area, but I don't. So next steps, we either dig further or plug it in again and see where it happens. I'll leave it up to you guys. I'll leave it to a vote. Alright, so I actually overlooked something here. You can see here, right under this board, it looks kind of burnt. So, might be an indication of what's going on. If it is in fact this board, I might be able to just make a new one. Or fix it. I don't know. We'll see. But regardless, if you haven't voted yet, go back and vote and figure out how we will proceed. Or plug it in again and see where it happens. I'll leave it up to you guys. I'll leave it to a vote. Alright, so I've got this thing plugged in. Power coming in here. And actually, I didn't even have to turn the radio on. I just had to put power, just flip the switch on the power supply here. And that's when it was going up in flames. So I'm going to flip it right now and see what happens. Ready? 3, 2, 1. Oh yeah. I had to turn it off there real quick. So there we go. We saw the flames. Ooh, that stinks. Oh, it's going to be all right. So I'm going to take this thing apart and flip over this board. See if we can fix it. All right, so I disconnected power. It looks like we just got to take off these wires here for incoming power, outgoing power, and then 4 screws. Just these guys here on each of these corners. We'll flip this guy over. All right, so there's the plate that was under the board, and this is the burnt spot on the board. So I did a little bit of reading, and I actually Googled this board, this B5143D, and once in a while this board has been known to grow tin whiskers, which then causes some connections that are close to ground to arc over. So I think that's actually what's happening here. The components, there actually used to be a couple capacitors there. Maybe they went bad, or the tin whiskers grew and it was arcing over to ground in here. So I'm going to scrape off all this gunk, see what's left of this board, and see if we have to replace part of the board, build a whole new board, or if we can just solder some new capacitors in there to replace it and get this thing up and running. Either way, I think I'm going to coat something, or coat this piece. So rumor has it there were a couple of capacitors on that circuit board. When you buy quality equipment, they give you the entire wiring diagram for the whole radio for each of the boards. So I need to find that board. Ooh, the filter board. This is it right here. So power coming in. Some of these capacitors right here. So I'll have to check to see what's still on the board and what's been completely obliterated. And then just replace capacitors, connecting these proper test points, and we should be back in business. Oh, and the hole where I scraped all the carbon, I'm just going to fill that with a non-conductive glue, and should be good. So I'll keep you guys posted. Alright, so that UV light cured the glue in like 60 seconds. Good to go. Looks pretty good. So what I'm going to do is, I don't know if I'm going to put the new capacitors on the back of the board, maybe coming off the other side, like right in here. Or maybe I'll just put it on top of the board from here to here. Either way, those capacitors are just bridging power to ground. And then that ground is actually chassis ground, which is grounded through these screw holes with these little pads here. When you screw it down, it grounds it to the chassis of the radio. So anyways, I'm going to sleep on that. Probably dig up some capacitors online tomorrow, order them up, and hopefully have this thing back up and running. Oh, I'm probably going to put this on the oscilloscope and the spectrum analyzer too. I want to see how good of a filter this thing actually is. We might even make some improvements if I'm feeling ambitious. Alright, so just taking a quick minute to dig up some capacitors here online. Mauser Electronics, one of my go-to sources for this kind of stuff. And I found this capacitor. It has the 0.0047 microfarad capacity rating. It's rated at 1500 volts, which is way more than we need. But in a capacitor this size, physical size, this is a pretty big one, relative to what we could be putting in there. This is 180 thousandths by 120 thousandths of an inch. That's physical size. So you figure, what, 3/16 of an inch by about 1/8 of an inch, give or take. And that's going to make it easier to solder on the board. Really, I'm not concerned about soldering the board because I can do that with hot air. But what it is going to make it easy to do is span the gap between the two sections of copper. So that'll make it easier. There are other smaller ones that are rated for like 50 volts, which would also work, but they're a lot smaller. We're talking about like 0402, which would be 40 thousandths of an inch by 20 thousandths of an inch, very small. And I physically don't think I could even put that across the gap. It just wouldn't fit. Specs wise though, X7R, this is a good dielectric for building filters and stuff, and having a low equivalent series resistance, which is what we want when we're building filters. So this is considered a multi-layer ceramic capacitor, so that MLCC comes from. I did find another write-up from another guy that had a similar problem with a similar radio, same board in that radio that failed on him, and he fixed it with different types of capacitors, and based on what I know, he basically didn't do it right, but we'll use this. Alright, so I've got some good news. A local supplier that actually did some electronics assembly stuff for me had some compatible capacitors on hand. They're local, so I was able to just come by and grab them. So that means I don't have to order them from Mauser, don't have to wait for them, I don't have to pay like 20 bucks in shipping for these tiny little things. Only needed a couple of them. So I'm not going to be able to install these today. Hopefully on Monday night is what I'm looking at right now, but at least I've got the stuff. So things are shaping up. I got the stuff. Stay tuned. Alright, so Monday came early, and we're going to go ahead and wrap this thing up today. I had some plans. We're going to have to shortcut after all because I don't have some of the proper equipment, but I'll explain. So this thing is well cleaned up. The other day I filled this in with glue just so we didn't have a thin spot in the board. It doesn't look like anything shorted out or anything. I trimmed off any of the excess copper that was flopping around there, so it came out pretty good. Now today I wanted to hook this thing up to the spectrum analyzer, but I'm missing one of my adapters for actually hooking it up. So we're going to have to do that on the day, which is probably better to do it this way anyways. Just, you know, fix it the way it was, straight from Icom, plug it in, make sure the radio still works, and then we'll probably tear it back down and take a closer look at this later. But basically what this thing does is cleans up the power coming into the radio. So, and what I mean by cleaning up the power is the power comes in here. This is where the power supply was plugging in. It's really just a 12 volt source. I can run this off a battery or off of a car, off of whatever. But ultimately, once the power goes through here, this 12 volts, when it comes out on this other end, you want it to be as clean and stable as possible. So you just want a flat, stable 12 volts. You don't want any sort of noise or like alternator noise or switching, ringing from switching power supplies or any of that stuff. You don't want any of that to come out the other end, if at all possible. And none of these things are perfect, but it would be interesting to put this on the analyzer and take a closer look at how effective it actually is. So, like I said, we're going to do that another day. So I'll flip this thing over and we'll get to soldering some stuff here. All right, so taking a closer look here, you can see that the solder pad here, where it had caught on fire, there were capacitors there, and now there's not. And those capacitors were similar to these two here. There's a couple different sets, and like these two here, and like these two here. So I'm assuming that the shape of this solder pad was similar to this one, but it caught on fire. So I was actually looking at just how the power flows through this board, and it's interesting to me that they even put the capacitors on the bottom of the board, because really those capacitors help filter out the noise, and you want those capacitors, theoretically it would be better if they were on top of the board, directly in path of the shortest way for power to get from here into this coil. So we're probably going to end up putting them up on top, just so it can drain off as much of the noise as possible within the direct shortest path from power from here into its next step on this board, which is going into this coil. So I'm going to end up scraping off this green stuff, and we'll get down to the copper, and then we'll drop our capacitors right on there. And then we'll break out the surface mount soldering stuff and see how it goes. I got the two capacitors in place here, right where I want them, and they are two different value capacitors. You can see this tiny one, 0.0047 microfarad and a 0.1 microfarad. And the way that the power flows from the plug from outside the radio comes down here, and it hits the 0.0047 first, and then hits the 0.1. So up here they labeled, the guys that gave me these things, it's actually Christine, she helped me out with this from a local company here. She marked them. The blue dot is the 4700 picofarad, which is the same as 0.0047 microfarads. So that one's got to be on here first. Like the power comes in, it's going to see this one first, drain off some ripple, it's going to hit this one, drain off some ripple, and then it's going to go into this. So next, go ahead and get the surface mount stuff ready to go. So when it comes to electronics, there are different types of, two basic classifications, I guess. This is like a surface mount component, and these are through hole components, because there's actually literally a hole and then you solder it. Whereas these are on the surface where they solder, they don't go through the board. So typically with surface mount stuff, when it's this small, you don't hand solder it with a normal soldering iron. You put solder paste on there, and then you melt it with a hot air soldering station, which I have. So we're going to try that first, but sometimes with boards like this that have really big areas of copper, the heat from the hot air will dissipate fast, and it becomes difficult to actually heat that up fast enough. So I'm going to try that first, but I might end up having to try to hand solder these things, but we'll see how it goes. We're just preheating this now with the hot air. It's set to 180 degrees Celsius, so it's about 360 degrees Fahrenheit. We'll let this preheat here for a few minutes, and then I'll go ahead and kick up the heat and then get that solder paste melted, and show you guys how that happens. Now I've got this set to 230 degrees Celsius, and you can see the solder paste is starting to bubble in there, and it should start to turn to solder. There we go. See those little tiny solder balls? Oop, it's kind of dancing around on me. Gotta chase it a little bit. Oh, come on. There it goes. Yeah, that's exactly what we want to see right there. All those little solder balls will start to mold into each other. And we're almost there. So I'll wrap this up and I'll show you guys a close-up completed picture of these things. Alright, so I've got those guys soldered in. I've got this filter just plugged into the power supply, same power supply we used to catch this thing on fire a few days ago. I'm going to go ahead and turn this thing on, and hopefully it doesn't catch on fire. If it doesn't catch on fire, we'll put it back in the radio and hopefully turn the radio on. So here we go. No fire. Cool. So I'll go ahead and plug this thing in the radio and give it another go. So I was about to put this thing back in the board, but this here, you see these little dots around these mounting holes? Those are supposed to be copper or solder plated dots that help connect the ground of this to the ground of the radio where the screws go in. So that basically grounds to here. Well, this radio is pretty old now, and so I decided to go ahead and just start retinning. This one's kind of messy. They just started doing them. I'm going to retin these little ground holes before I fasten this thing in the radio, just to make sure it's got a good ground. Again, this thing's old, it's dirty. You want to make sure you have a good ground, especially when you're trying to eliminate interference and all that kind of jazz. So I'm going to do that. So I've got it in here. I plugged it into the power supply. I have not plugged it into the radio yet. I actually got curious, hooked up the probe to the oscilloscope, and I wanted to see how stable the power actually is on here. So you can see that our power is actually about 14.25 volts with a variation of, figure about 50 millivolts peak to peak. So that's how much the voltage is varying there, is that 50 millivolts. So it's not bad, it's pretty good. Could be a little cleaner, but it's not terrible. Alright, hooked up, wired up, ready to turn this thing on. Hopefully I can turn this on, we won't see fire, and then hopefully I can turn this guy on, and we'll see this thing come to life. If so, I'll button her back up, take her home, be back on the air. So, but first, we're going to take a poll. Is it going to go up in flames, or are we going to be good to go? Alright, here goes nothing. No pops, no smoke, nothing weird, doesn't smell funny. Aha! There it is. Should be able to get back on the air. Oh, it doesn't have a speaker right now. I gotta put that back in too. I can't transmit because there's no antenna or anything, but radio's back to life. Good to go. So I just gotta put the speaker back in, sitting up here. Put this top shield back on, then put the normal top on. Then I'll take it home. It's actually not going to happen tonight, but I'll take it home, hook it back up, and get this thing back on the air, and I'll post that too. See if we can't make a couple contacts and see where they're at. Stay tuned.